So we want to talk about limits at infinity, horizontal and vertical asymptotes. But before that, let's sketch the graph of few functions to see what this idea is about. So graph of 1 over x looks like this. As an even, it's an odd function, so it's a reflection in origin. So this is how graph of f of x equals to 1 over x looks like. Now notice the following. If x goes bigger and bigger, then 1 over x goes to what? So if x goes bigger and bigger, that means x is, in that case, we'll say that x goes to infinity. That means x is getting bigger and bigger without any bounds. In that case, 1 over x goes to 0, right? Similarly, if x goes to negative infinity, that means x goes bigger and bigger, but the sign is, it goes bigger and bigger in the absolute value, but the sign is negative. In that case also, you see that if x goes to minus infinity, 1 by x goes to 0, right? We'll try to formulate this in terms of limits, but let's see a few more graphs. Same thing about e to the x. So the graph of e to the x looks like this at 1. It's like that, and then it's customary to put an arrow to say that, well, the graph will keep on going in that direction. In this case, as x goes to infinity, e to the x, this is a graph of e to the x. It looks very similar to 2 to the x, or 3 to the x for that matter, goes to infinity. But if x goes to minus infinity, e to the x goes to 0, right? You can see that it's going closer and closer to this axis and becomes 0. Similarly, let's look at tan inverse of x. So tan inverse of x is the inverse function of tan x. So it's a reflection of tan x graph in line y equals to x. So if you recall, this is how tan inverse x looks like. So you have basically pi by 2, you have minus pi by 2, and the graph looks more or less like this. Yeah, again, going in both directions. You can, in this case as well, if x goes to infinity, tan inverse of x goes to pi by 2. And if x goes to minus infinity, tan inverse of x goes to minus pi by 2. Okay. Now let's look at the next one, 1 upon x squared, 1 plus x squared. When x is 0, the function value is 1. But as x gets bigger and bigger, the function starts decreasing. And actually the shape of this looks like this. We'll be able to look at the shape properly when we are doing curve sketching, so using derivatives and stuff. But for now, you can look at the graph and this is how it will look like. Again, in this case as well, if x goes to infinity or if x goes to minus infinity, in both cases, 1 upon 1 plus x squared goes to what? 0. So early on, we were talking about limit as x goes to a. That means x is getting closer and closer to number a, right? But what does it mean by getting closer and closer to infinity? There's no such concept. Infinity is not a fixed number or fixed spot to which your graph gets very close to. But on the other hand, we understand if x get really larger and larger is what we mean by x going to infinity, right? So let's formalize that definition. We say, suppose f is defined on some interval from a to infinity. then we say limit as x goes to infinity of f of x is L. If what happens? If f of x can be made close to L by taking x sufficiently large. So the idea is this x going to infinity part is basically taking x sufficiently large. So this is what it means by x going to infinity. So let's see. So what if limit as x goes to infinity of 1 over x? In that case, we already saw this is what? 0. Similarly, limit as x goes to minus infinity of 1 over x is also 0. In fact, more than this is true. You have limit as x goes to infinity of 1 by x to the r is 0 if r is greater than 0. Okay. Right. What about limit as x goes to minus infinity of 1 over x to the r? Now, this is 0 if r is greater than 0 and x to the r is defined for all x. Now, what does it mean? Why do we have this extra condition as x goes to negative infinity? Now, notice the following. If x goes to negative infinity, and you have 1 by x to the power r, and r is half. Now, you see square root of negative numbers are not defined. So x going to negative infinity, for those x's, it's not even defined, right? So this does not exist. However, if you have limit as x goes to infinite minus infinity of 1 by x to the power 1 by 3, cube roots of negative number exist. And in that case, this will be 0. Yeah. So that's why we have to add this extra thing. As x goes to minus infinity, 1 by x to the r is 0 if r greater than 0 and x to the r is defined for all x. That means there's no problem like square root of x. Okay. Now let's look at the similarly limit as x goes to minus infinity of e to the x. So that's also we saw that is limit as x goes to minus infinity of, so as x goes to minus infinity, e to the x goes to what? 0. So this is going to be 0 as well. Now you saw that tan x goes to infinity of tan inverse of x is what? From the graph, you can see that that is going to be pi by 2. So this is going to be pi by 2. Similarly, x goes to minus infinity of tan inverse x is minus pi by 2. Again, it comes from the graph, right? The graph of tan inverse looks like this. Yeah, there's not a straight line. It's growing up slowly, going towards this pi by 2 value. So you see this line becomes special for the tan inverse graph, right? So this horizontal line, y equals to pi by 2 and y equals to minus pi by 2. These horizontal lines are special lines. They are what is called as horizontal asymptotes. So we call the line y equals to L as horizontal asymptote if either x goes to infinity of f of x is L or x goes to minus infinity f of x is L. So let's see. In this case, what do we get? In this case, what is the horizontal asymptote? So since you have limit as x goes to infinity of 1 over x is equal to L, and what is your L? Your L is 0. Y equals to L, which is same as y equals to 0, is horizontal asymptote. I'm using the short for horizontal asymptote as HA. You can write the full thing, horizontal asymptote. Yep. Similarly, limit as x goes to, so plus or minus infinity is 1 over x. So you get horizontal asymptote in both directions. In this case, although limit as x goes to infinity, e to the x is not a fixed number, is actually infinity. So this doesn't give you any horizontal asymptote. No horizontal asymptote in this direction. That means as x goes to infinity, f of x is not getting closer to any value. However, you see that limit as x goes to minus infinity of e to the x is 0. So this would mean y equals to 0 is the horizontal asymptote. Okay. So let's look at the next one. In this case also, you see limit as x goes to infinity of tan inverse of x is pi by 2. So therefore, y equals to pi by 2 is a horizontal asymptote. Similarly, x limit as x goes to negative infinity of tan inverse x is minus pi by 2. So therefore, y equals to minus pi by 2 is a horizontal asymptote. So the graph has two horizontal asymptotes. And note that you cannot exceed more than 2. Yeah. Same thing about this guy as well. The horizontal asymptote is, in this case, is what? Y equals to 0 is the horizontal asymptote. Yeah. So you get horizontal asymptotes in this way. So now, this is rewritten what I've written earlier as if r is greater than 0, x goes to infinity, 1 by x to the r is 0. Yeah, limit of this is 0. Similarly, if r is greater than 0, then and x to the r is defined for all x, then 1 by x to the r, limit of x goes to minus infinity is 0. Note that only rational powers are defined in this case here. So this is a property. So these two things are the important things which we'll be using to find out limit of x goes to infinity or minus infinity. So let's embark on this problem. Limit as x goes to infinity of this 3x cubed minus 4x squared minus 1 divided by 6x cubed plus x plus 2. We want to find out what is limit as x goes to infinity. Now, we don't really know about the limit as x goes to infinity behavior, except limit as x goes to infinity of 1 by x to the r is 0. So we need 1 by x to the something here. We do not have that, so we'll create it. How will we create it? We'll divide both numerator and denominator by highest power x to the power something, and that power would be the highest power in the denominator. So you always divide by the leading term of the denominator. Why denominator? Because it will keep the expression simpler. All right. So let's work on that. So limit as x goes to infinity. I'll divide top and bottom by highest leading term. We can divide top and bottom by x cubed. So x cubed. You can also divide by 6x cubed, but x cubed is better. So 6x cubed plus x plus 2. Whatever you divide on top, you have to divide on denominator as well. Now this will simplify to limit as x goes to infinity. This will become 3 minus 4x squared by x cubed is going to be 4 by x minus 1 by x cubed is going to be 6 by x cubed, 6x by x cubed, which is 6 plus 1 by x squared plus 2 by x cubed. And now we know that limit at x goes to infinity of 4 by x is going to be 0, 0, 0, 0, right? So then the limit is simply going to be 3 by 6, which is 1 by 2. So this is how you evaluate limit as x goes to infinity. Okay, let's move on to the next problem and see. In this case, so again, we divide by the highest power of denominator. So what is the highest power of denominator? X to the power, the highest power in the denominator. So we'll divide both top and bottom by x. So limit as x goes to negative infinity, 3x squared minus 5 divided by x, 2x plus 5 divided by x. Now this is going to be limit as x goes to negative infinity, 3x squared minus 5 minus 1 by x plus 2 plus 5 by x. Now to be able to simplify this part, I need to push this x inside the square root sign. So how do I put it? So note the following. If you have x is positive, then if you take x squared and square root of that, you get back x. Yeah, take an example. For example, 2 is a positive number. So if you take 2 square and then take square root of this, you'll get back 2. However, if x is negative, then say let's take minus 2. Minus 2 square root gives you back what? 2. It doesn't gives you back minus 2. But if you want minus 2, you need to put a minus sign in front of it. So if I write this in terms of x, so this is going to be x squared minus sign is equal to x. So this is the difference between x greater than 0 and x less than 0. So now in this case, if I want this part to be inside the square root sign, I will have to replace that by limit. So this is an extra discussion, not part of the solution. Limit as x goes to minus infinity, 3x squared plus 5 divided by, instead of x, I'm going to write x squared with a square root with a minus sign on 1 by x, 2 plus 5 by x. Now I can push this x squared inside the square root. Why? Because square root of a divided by square root of b is square root of a divided by b, right? You can write them in the common radical. Limit as x goes to infinity, minus infinity, 3 plus 5 by x squared, square root. This minus sign will prevail. So minus sign 1 over x plus 2 plus 5 by x. Now as x goes to infinity, this guy goes to 0, this goes to 0, this goes to 0. So we have, the answer is minus root 3 by 2. So that is the answer for this guy. So as x goes to infinity, where does x squared goes? So think about it in the following way. If x goes bigger and bigger, x squared goes bigger as well. So this is going to be infinity. Now, what about this case? X goes to infinity. So we'll divide by the highest power of x. So x to the power, so x to the highest power of the denominator. Why? Because it is easier to keep the denominator simple. So you get x goes to infinity, divide top and bottom by x squared by x cubed plus 2x by x cubed minus 1 by x cubed. Then you have x cubed by x cubed plus 3 by x cubed. And in that case, you'll see you'll get limit as x goes to infinity of 1 by x plus 2 by x square minus 1 by x cubed upon 1 plus 3 by x cubed. And now as x goes to infinity, this will go to 0, 0, 0, 0. So 0 over 1, which is 0. All right. All right. So next, let's move on to the next one. Limit as x goes to infinity. So again, we'll divide by x to the power, the highest power of denominator. So here we'll get limit as x goes to infinity, x4 divided by x squared plus 5 x cubed divided by x squared minus 1 upon 1 plus 1 by x plus 1 by x squared. right? And this is going to be limit as x goes to infinity 1 x square plus 5x. Here also we had x square, sorry about that, minus 1 by x square over 1 plus 1 by x plus 1 by x square. Now this is going to be limit as x goes to infinity. Now these guys will go to 0, 0, 0. But x squared plus 5x, where does that go to as x goes to infinity? So whenever you have a polynomial and you take polynomial as x goes to infinity of that polynomial, the limit will be the limit of the leading term. What do I mean by that? Suppose I take a polynomial p of x, zero, and an is not 0. In that case, limit as x goes to infinity of px is going to be same as limit as x goes to infinity of an x to the n. You can basically ignore the other terms because this is a dominant term. It will decide where will the whole thing go. And you can check it out. This is going to be infinity if what? If an is greater than 0. Right? So if an is greater than 0, this will go to infinity for sure. However, if an is less than 0, this will go to minus infinity. Right? Similarly, we can make a similar argument about limit as x goes to negative infinity of p of x. In this case, we'll get this is same as infinity if what? If an is greater than 0 and n is even, means the leading term is the leading power is the highest power or the degree is even, will also be the case if n is less than 0 and n is odd. And it's going to be negative infinity if what? If n is even, but an is negative or an is less than 0, or if n is odd and an is greater than 0. So this decides. So this may look slightly complicated, but actually the idea is I'm looking at the leading term and I'm deciding where it's going to. So in this case, if you look at the top polynomial, the leading term is 1, and as x goes to infinity, leading coefficient is 1, or you can look at the leading term as x goes to infinity, x square goes to infinity. So this limit is going to be infinity. It's all about the leading term when you're looking at the polynomials. Similarly, we have already seen that this limit as x goes to infinity of e to the x is infinity. Now, what is limit as x goes to infinity of e to the power x over x squared? The answer is infinity as well. We'll look at the precise reason for this when we are doing L'Hopital's rule. But for now, you can think about it in the following way. E to the x and x squared. Now the numerator, when it goes to infinity faster, way faster than the denominator, then it will go to infinity. If the denominator goes to infinity way faster than the numerator, then the limit will be 0. And by way faster, we don't mean just multiple, but some power. Okay. So we'll make this precise when you're doing L'Hopital's rule. So I think that's it for today.